Hi folks, welcome to the 6.3 practice, and this practice will be on shell method. So we're going to take a moment to take a look at question number 1 in this video. And as you can see, we're going to be looking at one problem, but we're going to solve it 2 different ways. The first way that we're going to solve this problem is using washer method, okay? So a method that we know. And then we are going to solve this using shell method. So that's a newer method for us, but I want us to see that we could, in some cases, use either method and still get to the same answer. All right, so let's take a look at question number 1. It says, find the volume of the solid of revolution generated by rotating the area between the graphs of f of x equals the square root of x and g of x equals 1 over the interval from 1 to 4 around the x-axis. And so what we're going to do is we're going to sketch our graph. We're going to make f of x be the orange one, and we will make g of x be this light blue one. Okay, so we've got an orange curve and a blue curve, and I'm going to go ahead and draw the diagram for washer method first. So the square root of x, I can always plot a few points. I know that 0, 0 is a point. I know the square root of 1 is 1. And then the next nice point really is like the square root of 4 is 2. So those 3 points are nice to give me a good sketch of the curve, and then I can connect those like that. Now the other curve was g of x equals 1, and that's the same as saying y equals 1, and so that means we're going to get a horizontal line at y equals 1. And so that will give me a horizontal line right here at 1, okay? Now I can see one very clear intersection point. I see it right over here. And I'm going to go ahead and write the coordinates for that. But I also see another ending point based off of the interval that they gave us. So they said start at 1 and end at 4. So that's where my ending point is going to be. So that means I'm going to stop here. Let's do that again. It's going to stop right here. Okay? And the coordinate of this point is 4, 2. All right, so now I can see the region that I'm rotating, which is between the blue and the orange and the pink curve. And so I'm going to go ahead and draw my reflection for washer method. So that means that I've got a point here, I've got this point here, and this one, and I can seal off that region, and this is the blue line, and then I have this curve part right here, okay? Now, if I'm doing washer method, we've been practicing drawing some lines, and I think what's important is that we think about how those lines compare to our axis of revolution. So my axis of revolution here is the x-axis, which is right here. Okay, so there's my axis of revolution. Now, if I were to draw some rectangles, okay, if I want to use washer method, like if I've decided I want to use washer method, then my rectangle lines have to be perpendicular to my axis of revolution. Okay, so if I choose washer method, my rectangles are perpendicular to my axis of revolution. That means that if I drew a line like this, that would be wrong for washer method because this green line is parallel to the yellow line. So let me undo that, and instead I'm going to draw some lines that are perpendicular. So here's one line, here's another line, here's another line, and these lines are just sample rectangles and they are perpendicular to my axis of revolution. And so when I think about this case, I definitely see that I have a big hole inside of my shape. All right, so right here is the hole. And so I need to think about a big R and a little r. Okay? So let's think about how to set this up. If I know that I'm using washer method, then I'm saying that the volume equals pi, the integral from a to b of big R squared minus little r squared dx. Now, I know that I'm going to have the pi in the front. I even know my bounds are going to be 1 to 4 because I pick the x value here and the x value here. Now, I think it's hard sometimes for us to figure out what the big R is, but the big R is the one that is further away from the axis of revolution. And so I can see from my graph that the orange line is further away from the axis of revolution. So my big R is going to be the orange curve. Now, similarly, I can see that that light blue line is closer to the axis of revolution. So that makes the light blue line my little r. So my big R, according to my equation at the beginning, was the square root of x, and then I have to square that because it's big R squared. Minus the little r was just 1, and then I need to square that to get little r squared, and then I seal it off with a dx. All right, so now let's go ahead and simplify. So pi, the integral from 1 to 4 of x minus 1 dx, which equals pi times 1/2 x squared minus x, vertical line, put a 4, put a 1. All right, let's plug in our bounds. So I'm going to keep the pi way out in the front, and I'm going to have 1/2 times 4 squared minus 4 minus 1/2 times 1 squared minus 1. And let's see what happens when I simplify. Okay, I'm going to get pi, and I'm going to get 16 over 2 minus 4 minus 1/2 plus 1, which equals pi 15 over 2 minus 3, which equals pi 15 over 2 minus 6 over 2, which gives me a final answer of 9 pi over 2. Okay? So, here is our solution for question number 1 using washer method. So we're going to stop this video here, and when you come back in video number 2, we're going to look at the same problem but using shell method. All right, I'll see you there.